Hey televisions, back with me again, Aji Gautama Putrada. I am your lecturer for operating systems. This is meeting 9 virtual memory part 1. In the first video, we will be discussing about root page tables. Stay tuned. So in the last video, we have calculated that a 4 gigabyte virtual memory with 4 kilobyte page size needs a 4 megabyte page table. Now, if this 4 megabyte before we continue, so this 4 megabyte page table is in the virtual memory as we discussed. This is inside the virtual memory. And because the size is so big, we can divide it again into small page sizes. And don't forget that each page size is 4 kilobytes. So how many pages are there in this page table? There are 4 megabytes divided by 4 kilobytes, which equals 2 power 22 divided by 2 power 12, which equals to power 10. So there are 1 kilo pages. And if there are 1 kilo pages and each PTE is 4 bytes, it means that there are 4 kilobytes of a new table, and this new table will be called a root page table. And this new table, compared to the 4 megabit page table, is far more smaller. So this new table, 4 kilobytes, can be put inside the main memory. So this is inside the main memory. So the hierarchy of the page table will look like this. So there is a small page table with the size of 4 kilobytes, and this is inside the main memory. This is small, and this is inside the main memory. Memory. And we have this root page table addresses a larger page table with the size of 4 megabytes. This is large, and this is inside the virtual memory. And this page table addresses each page which is inside the virtual memory, which has the size of 4 gigabytes in total. And this is the mechanism of a two-level paging system. So like before we said, we have two levels, and each level has 10 bits to address because there are 2 power 10 amounts of uh, page table. So here the 10 bits goes to the root page table, and it finds the virtual address of the page table. So a page table to address another page table. So this address is used, and it is combined with another 10 bits address. So it makes 20 bits of address, and then we search the 20 bits address inside this part of the greater page table. So we find 20 bits, and this 20 bits is then combined with the 12-bit offset, creating a 32-bit address, and then that 32-bit address is used to search for a physical address that is inside the virtual memory. So that is the mechanism. So that is the end of our third video. In this video, we have successfully discussed about root table and the mechanism of to level paging. In the next video, we will discuss more about virtual memory paging, so stay tuned. Thank you for your attention.